My name is Shreya Upadhyay. I ha- I have done my masters in botany from University of Mumbai, and currently I'm giving my presentation on manuscript that I have selected myself, that is exocrine proteins, including trypsinogen as a key biomarker in type 1 diabetes. But before going through this topic, let us first try to understand what exactly type 1 diabetes is. Type 1 diabetes is an autoimmune disorder in which sometimes because of because of weakened immune system, when immune system is not able to detect itself from harmful bacteria or its own body cells, by mistake it starts attacking its own body cells. And sometimes if it attacks pancreatic cells, that is islet of Langerhans, this causes pancreas this definitely kills pancreatic cells that produce insulin, and this causes insufficient insulin, as you can see. Due to insufficient insulin and diminished insulin level, the glucose starts increasing in our body, and because of this, the transporters are not able to transport glucose into different cells of the body. Due to this, due to this due to this, glucose uptake is diminished. And because of that, if it is not treated for a longer duration of time, it leads to a condition that is known as ketoacidosis, due to in which the body is not able to utilize glucose, and it start utilizing fat as a major source of energy. Now, the the topic that I have selected is exocrine proteins, which includes trypsinogen as a key biomarker in type 1 diabetes. Trypsinogen acts as a digestive enzyme, and there are two type of proteins mainly, that is endocrine and exocrine proteins. And trypsinogen over the years, its role has been discovered on how it can play an important role in um, in controlling glucose level. So here here this research was done in the university of research was done in the University of Bristol. This research was done in University of Bristol, where they where authors from different various departments had collaborated, and they had designed proteomic they had discovered about proteomic tools that can be used as a biomarker that can help in diagnosis of type 1 diabetes before the actual symptoms can start. So this document over here is a scientific study that explored the relationship between pancreatic function and type 1 diabetes. It basically shows that how decreased level in decreased level in trypsinogen impacts impacts individuals with the type 1 diabetes. And it also highlights trypsinogen as a potential biomarker which can be which can be used to which can be used to which can be used to which can be used in the future as a potential diagnostic tool for diabetes. Here, the corresponding author is Professor Kathleen Kathleen Gillespie. Professor Kathleen Gillespie, she has done her bachelor's from Galway and her doctoral from University of Wales. Currently, she is working as a professor of molecular medicine in Bristol Medical School. She has led diabetes and metabolism research since 2014, and she is a molecular biologist, and most of her past work from the year 2000 has mainly been in the field of molecular medicine, where she had where she had where she had where she has dealt where she has mostly d- where she has mostly where she has mostly done her research related to the molecular genetic mechanism in type 1 diabetes. Currently she is working on several currently she is working on several projects, and her projects might help in in determining the cure for diabetes, and her projects in the future might be useful in finding out on how diabetes can be detected before the symptoms can start. So currently her projects are being funded by various various charitable institutions in European Union as well as UK. Now, historically, type 1 diabetes has been viewed with having a possible symptoms, that is polydipsia, polyphagia, and polyuria. And moreover, it is an autoimmune disease which targets endocrine pancreas, and that results in the destruction of insulin, that is producing beta cells. But recent research has started to acknowledge the involvement of exocrine pancreas, in which in which research has shown that some of the individuals often often exhibit not only defect in endocrine functions, but also their pancreatic volume get decreases, and exocrine dysfunction have also been registered. And due to this, it also leads to deficiencies in many of the exocrine enzymes, that is trypsinogen. And some research have also shown that early detection of type 1 diabetes through biomarkers can play an important role in prevention of the disease progression. Hence biomarkers is really an important thing. Biomarker is really an important thing, which can be used as a novel diagnostic tool technique. Proteomic studies proteomic studies have also recently shown in the development of biomarkers. They they are used they are used to study about the immune response and inflammation that body occurs. And thing is, the currently the study is being focused on exocrine proteins. Okay. So, traditionally, type 1 diabetes has been an autoimmune disorder because the most function because mostly researchers focused only on endocrine function, not on the exocrine function. But nowadays, studies progress, they have shown involvement of exocrine pancreas also. So lot of research in this in this is going on. So, after reviewing this review paper, I came across question is that what can be the differences of exocrine enzyme levels in between monozygotic twins for type 1 diabetes and healthy control? And can trypsinogen really serve as a biomarker for type 1 diabetes in various populations? Because sometimes these levels can vary as per the ethnicity and race of the people, and sometimes is really lower trypsinogen levels increased with the risk of type 1 diabetes progression. And most important thing, what are the clinical factors that actually influence type 1 diabetes? So, the objective to conduct this research was to investigate the role of exocrine protein, especially trypsinogen, which can be used as a biomarker for type 1 diabetes. And also, it was done to identify and validate trypsinogen as a as a predictive biomarker, which offers early diagnosis before the disease starts progressing. So biomarkers are a biological molecule that are found in blood or any body fluids or tissues that is that is a sign of and this is a sign of a normal and abnormal process or any disease condition. A biomarker is usually you may be used to see how body responds to a treatment for a disease or a condition. Okay. Now, in this research, they had done this research on a monozygotic twins which were identified with which were diagnosed with type 1 diabetes. So, before the time of diagnosis, how their trypsinogen level was, and after the diagnosis of type 1 diabetes, how trypsinogen level actually fluctuated. This is given in this flow chart. So, so they actually took they actually studied 4686 4068 proteins. Screening was done, and the type of biomarkers they identified were chymotrypsin, trypsinogen 1, trypsinogen 2, and etc. And after identification of this trypsinogen, they identified they identified through biostatistics that which pairs which pairs of trypsinogen which pair which that whether twins affected with diabetes had lower trypsinogen versus people who are non affected versus people who are not diagnosed with diabetes at all. So they had taken serum samples from all of these people, and they found out that uh, and they found out that the decreased trypsinogen level is mostly associated with the risk of type 1 diabetes, and insulin and decreased trypsinogen level also leads to increase in insulin dose and diabetic ketoacidosis. So research method that was used over here for proteomic profiling is a SomaLogic. SomaLogic is a SomaLogic SomaLogic is a software which is SomaLogic is a software which is used to it is used to measure high and low abundance proteins confidently with superior sensitivity, high specificity, and proven reproducibility. So, this allowed them to screen 4,068 human proteins in a multiplex assay, and that led them to the analysis of many serum samples. After the analysis, they this research involved diverse clinical participants with type 1 diabetes, those who are relatives of it, and control participants included healthy people who haven't been diagnosed with diabetes. So this serum sample was taken from various people. After that, whatever the results were obtained, they use parametric statistical analysis such as Mann-Whitney U-test, Pearson and pair rank correlation test, and they use this to assess relationship between trypsinogen levels and clinical characteristics. And also it gave the interpretation related to disease progression and agreement of the different sample conditions. And to put this all together in a more simple way, they used another statistical model, that is nested linear mixed model. it uh, which helped them to compare trypsinogen levels between participants and siblings, and they were adjusted for various demographic and clinical variables. The new technique that was used over here the new technique that was used over here was somalogic platform from proteomic analysis. This study actually allowed them for proteomic analysis. They utilized this by somalogic platform version 4, and this advanced platform allowed them to um, assay proteomic profile samples of 400 and of 4068 proteins. And the use of SOMAmers ensured high specificity and sensitivity in detecting protein levels even at a low concentration. Another new technique that was being used Another new technique that was being used is trypsinogen assay optimization. In this they used a diagnostic kit, that is Dolphia neonatal kit. It allowed them to optimize the detection of low trypsinogen levels, which played a crucial role in identifying pancreatic exocrine deficiency in type 1 patient. The thing is, the advantage of this was that it allowed the validation through various cycles, which ensured stability and reliability of the measurement. Now, here are the results that were being obtained. The study actually found out that the trypsinogen levels in type 1 diabetes patient was lower compared to their healthy siblings, and compared to their healthy siblings and control participants who never had type 1 diabetes. So this suggested a potential association of decreased trypsinogen levels and presence of type 1 diabetes. Correlation with disease progression. The research actually showed a positive correlation between trypsinogen level, and sometimes age factor also played and how the age factor played role in the individuals of type 1 diabetes. So this showed the potential link between trypsinogens and when the disease would have actually started. This also showed that this also showed that the lower trypsinogen levels was in this lower trypsinogen level increased as the risk of type 1 diabetes progressed after years of diagnosis, and this was this was recording using hazard plot function. This finding also this findings also lead to understanding that trypsinogen serves as a key biomarker, and it highlights the potential of exocrine biomarkers in understanding the disease. Table 1 basic it shows Table 1 statistically shows the strong correlation of in monozygotic twins, because the monozygotic twins and uh, monozygotic twins, that they have been associated with reduced level of trypsinogen compared to the control participants. So this also showed this also showed the top this also showed the top this also showed that how they are also related to type 2 diabetes as well. How trypsinogen is also decreased trypsinogen is also related to type 2 diabetes as well. Mm, table 2 Table 2 shows about somologic proteomic profiling, in which it is used in which this shows various proteins that is related to pancreatic function. It actually highlighted the importance of exocrine proteins in relation to type 1 diabetes, and it provided a comprehensive view of the proteins that are identified in this study. And uh, and uh, here and this level and this table shows paired t test in which type 1 diabetes has been detected, and on top of that, the differences between monozygotic twin level and control levels have been showed. Now, the figure 1, which is obtained from somalogic, shows that twins with type 1 diabetes showed the decrease in trypsinogen level. Meanwhile, twins with no with type with without type 1 diabetes showed that they have they have normal trypsinogen level. Meanwhile, controls also had a normal trypsinogen level, but but in comparison to twins, those who didn't have diabetes, and control people, those who didn't have diabetes, their trypsinogen level was normal, but monozygotic twins showed decrease in trypsinogen level. Here, here the figure to highlight that how age plays an important role, in type 1 diabetes trypsinogen level. The thing is, here, so here in the twi- the here the here as the age started progressing, trypsinogen level started started decreasing as per the age as started decreasing as per the age. Here figure 3 here the figure 3 is here the figure 3 is, shows that as the trypsin here the figure 3 shows that how trypsinogen level and their progressing to type 1 diabetes is associated. It represents that the increased risk of lower trypsinogen trypsinogen level increases increases as per age by age. Whenever the higher the age, the more is the risk associated with lower trypsinogen level. Conclusion: the main conclusion that is trypsinogen is trypsinogen levels are obviously lower with individuals with type 1 diabetes compared to those who don't have type 1 diabetes. Age factors, BMI, physiological factors are also related to trypsinogen levels, which impact, and this also impact the pancreatic function. It also shows that that the trypsinogen can be used as a biomarker for predicting pancreatic atrophy, exocrine function, and also in understanding relevance with type 1 diabetes. And the findings also suggest that type 1 diabetes results in affection in type 1 diabetes affects both endocrine and exocrine functions of pancreas, and this also suggests that further research in both of these implications is needed. Key findings: the most important finding is that trypsinogen levels are lower compared to those with normal patients in type 1 diabetes, and age and BMI plays important role in determining trypsinogen level. However, this also highlighted that the biomarker trypsinogen can be used in predicted pancreatic atrophy and exocrine function. So this can be used as a diagnostic and prognostic proteomic tools for pancreatic health and type 1 diabetes. So the thing the so eh, so for example, if in an individual a lower trypsinogen has been found in serum levels, and there has been differences in terms of protein levels that is detected using proteomic tools. So we can make we can make this that so we can conclude that this individual is prone to type 1 diabetes in future, and we can detect the onset of this disease. So the thing I learned is that obviously type 1 diabetes historically it is uh, it is uh, it is related to increased blood sugar level because of autoimmune disease. There are so many factors that affect type 1 diabetes, but as manuscript highlighted, it is important for us to search into more biomarkers which can help us in designing uh, innovative diagnostic tools for the future. And also I feel that proteomics and genomics in this field plays an important role nowadays in uh, in detecting and diagnosing of various diseases. So the future thing is, if I had to carry this research forward, I would like to explore various diabetes cases, not only type 1 but type 2 as well. I would like to include more proteomics and genomics into it, validating the validating findings in diverse populations, and also how genetic and environmental factors affect to it, and what are the mechanisms that affect pancreatic exocrine function, and also how trypsin levels over the time increases or decreases. These are the references, and thank you.